we'll talk about budgets and choice. Now, I hope you have a budget. It's a useful part of personal financial planning. But even if you do have a budget, you may not do it quite this way. This is a pretty abstract view. We start off with a super simplifying assumption that there are only two goods in the world that we could buy, X and Y. Yeah, I know, really imaginative labeling there, economist dudes, but we don't want to add unnecessary complications. The amount of the good X that we can buy is on the X-axis, and the amount of the Y good we can buy is on the Y-axis. Suppose the price of X is $2 and the price of Y is $1, and I have $10 to go shopping. Not exactly a high budget, but keeps the numbers a little simpler. We can buy any bundle inside the budget line or right up onto the budget line if we spend all our money. If we only buy Y, then we can buy 10Y and 0X, because zero money left over. That's the point 0 on the X-axis and 10 on the Y-axis. Alternatively, we could spend all our money on X, buy 5 of X because they're $2 a piece, and have 0 left over for Y. That would be the point 5 on the X-axis and 0 on the Y-axis. Or we could buy combinations. Purchasing 4X means spending $8 on X, and that leaves $2 to spend on Y. So 4X and 2Y. If we can buy fractional amounts of X and Y, we could buy maybe 4.78 units of X and some fractional amount of Y. Now, what happens if the price of X, which we call PX, rises? What happens to the budget line? If X goes from $2 a piece to $2.50 a piece, then how many X can I buy if I spend all my money on X? The answer is 4. I can buy fewer X as its price rises. An increase in the price of X is going to decrease the amount of X that I can buy, so the budget line will tilt inward. It pivots around the Y-intercept point. Because if the price of X goes up, that does not at all change how much Y I can buy if I spend all my money there. If the price of X is 2 or 2.5 or 3, still I can buy 10Y if I spend all my money on Y. That point's not going to shift, but the budget line will tilt inward as the price of X rises. Now, vice versa, if the price of X falls, if X is just 50 cents, then the budget line will tilt outward. If, on the other hand, the price of Y were changing, then the budget line would pivot around the X-intercept points. If both prices change, then we'd just do one and then the next. If the person's budget increases, then both the Y-intercept and the X-intercept would increase. If the budget increases without a change in price, then the budget line shifts parallel outward. If the budget shrinks, then there's a parallel shift inwards. This is a super simplified situation. Maybe you're thinking you'd like to buy more than just 2 goods. Maybe you spend money on more than 2 things. Yeah, you do. We all do. Most of us, anyway. Maybe if you're a monk or something, maybe if your life is really simple. But most people purchase more than 2 goods. We have that restriction just to keep the mathematics simple. 2 goods makes it easy to graph in a 2-dimensional plane. If I had 3 goods, and I'd graph that in 3-dimensional space, n goods, and it would be a graph in n-dimensional space. And I don't know about you, but trying to visualize 8-dimensional hyperspace just hurts my brain. But the math don't care. Now, anyway, we'll go back to 2 dimensions. Budget line represents just some simple algebra. Hopefully you remember your algebra from back in high school. Our total budget is represented by B, and it's spent on X and Y. The amount of money spent on X is how many units of X are bought times the price of X. The amount of money spent on the amount of money spent on X is PX times X. Then the amount of money spent on Y is PY times Y. Adding those together should be equal to the budget. I mean, the total amount spent could be less, but graphing inequalities, it's slightly a pain, so we'll just graph the equality if we're right on the budget. B is the budget, and that has to equal px times x plus py times y. Rewrite that to get y on the left-hand side, since that's how we did it back in algebra class. Y equals b divided by py minus the ratio of px to py times x. That's rather formalistic about how the budget line is derived, but one of the assumptions that we kind of slide in there, which makes obvious sense in the mathematics, but not necessarily in the real world, is that the budget is linear, that the price of X doesn't change depending on how much X is purchased. But that's obviously false. I mean, people go to Costco or at Starbucks, a venti has twice as much liquid as a tall, but it's not twice as expensive. They're not charging you a certain price times the amount of liquid or number of ounces in the coffee. It's not actually linear. Next time you go to a coffee shop, you could calculate the price per ounce depending on the different sizes. But that means the budget line gets more complicated. It got zigs and zags, jumps and kinks and discontinuities, and so the algebra would also get a little more complicated. Next, we note that a lot of things in the world actually do not have a simple money price. There's plenty of debate around the question, does money buy happiness? I'm not going to get into that now. But there are things that do not have a simple money price. Nevertheless, the graph shows we can still express many of those costs in money. Define opportunity cost as being the things I have to give up in order to get something. That includes money, but it's bigger than just money. The whole value prop of why are there bodegas on every corner? We all know the prices are higher, but they're very convenient. I mean, you could shop around and find a place that's cheaper, but you'd have to go farther out of your way. The overall opportunity cost of buying something in the corner deli is that it costs more money but costs less time. That combination is the opportunity cost, which shows a money price that people are willing to pay for convenience. For a lot of entertainment, the cost is the opportunity cost. To watch a show or play a game, you have to see some advertisements. Most give you options for, you could pay a little more and see fewer ads. That's the trade-off between money and time. Opportunity cost extends to even bigger things. For instance, what's the cost of college? For a lot of people, certainly most students at City College, the biggest cost of college is the fact that you're not out earning wages. A student getting financial aid pays a lot less money, but still has a very high cost. When you're in college, you're not working, or not working as much as you could. Maybe you've got a full-time job, but if you can hold down a full-time job and full-time school, then you could maybe do 2 full-time jobs. You're giving up income in order to come to school. That's still good. Even counting all that income given up, it remains a hell of a worthwhile investment, delivering something like 5x return on your investment. You cannot get that kind of return elsewhere. Anybody on Wall Street would be desperate to grab an investment returning 5x. And CCNY is ranked number 1 in the nation for return on investment among all the colleges. MIT is number 2, Princeton's number 3. So I am not in any way discouraging you from making that investment. I'm just being realistic. Alternatively, and this is something I see a lot, people give up GPA in order to get income. Right? They work more hours, get a lower GPA, and probably a lower return on their investment in college. That's a question of discount rates. Rational people should be willing to take out a student loan if they believe that the rate of return from better GPA in college will pay off a higher rate of return. Anyway, back to the graph. We can say the opportunity cost of getting more X is giving up some amount of Y. Staying on the budget line, if I had previously purchased 3X and want to go to 4X, what's the opportunity cost? What do I have to give up? In this case, the opportunity cost of 1 more X is that I have to give up 2Y. Moving from the budget, which is often a straight line, to a more complicated function, we call this the production possibility frontier, the PPF. This shows how much of 2 different things, X and Y, can be produced. Unlike the budget line, where the price is often constant, in this case, the slope of the PPF changes. It has this kind of bowed out shape. For example, let's say there's an individual making choices between 2 things. On the x-axis, grades in school, some measure of how well they're doing. On the y-axis, some measure of physical fitness. Hopefully you're all at some good point, balancing doing well in school and keeping healthy overall, but there's a certain amount of time in the day, so there are trade-offs. Maybe you decide, all right, got to do better in school, even if I can't get to the gym as often. That means fitness sags down, but you get better grades. As X increases and Y decreases, you move to the right and down along the PPF. Now, there's probably decreasing returns on both of those. It's not like a fixed money price. If I spend one more hour studying a day, then my GPA goes up a certain amount. If I spend 2 hours more a day studying, or 3 hours more, or 4 hours, is my GPA going to rise at the same pace? No, it'll probably go at a decreasing rate. It'll still go up, but that rate of increase is going to diminish. It'll flatten out. Same if you spend 2 hours in the gym, or 3 hours in the gym, or 4 or more, then you certainly get more cut, but at a diminishing rate. That's why there's that sort of bowed out shape. It's not a straight line. Now maybe you're thinking, well, what is the relevant time frame? Sure, if I work out today, I will have less time to study today, but maybe over the longer horizon, I'll have more energy to study. Exactly. The PPF combines assumption about a certain time period. If this is for a whole economy, there may be various technologies that can shift the whole production possibilities frontier outward. It's like having a bigger budget in the previous graph. Or the technology may twist the PPF in different ways. As another example, if this is the decisions made by a whole society, maybe X is cheap gasoline and Y is a clean environment. Probably most people would like to be somewhere in the middle. Get a reasonable amount of cheap gas and a reasonably good environment, but obviously opinions vary. Some people would like to move down and to the right, get more X, less Y. Other people might want to go in the opposite direction. The key is that if everybody wants to go up and to the right, that's not actually feasible. There are going to be trade-offs. The budget line was a straight line with a simple algebraic expression. This has a little more complicated mathematics behind it, but it's probably a little more realistic about how the world works, where there are diminishing returns. Going back to the opportunity cost, which is how much of one good you'd have to give up to get more of the other good, in this case it varies since the slope varies. To get one more X, how much Y do I have to give up? Now that depends on how much X I already have. The slope of that production possibility frontier is changing depending on the value of X. If you've done a course in calculus, or if you're currently doing a course in calculus, then the idea of the slope of function changes depending on the value of X is perfectly straightforward. Calculus is all about finding neat relationships between the value of X and the slope of the function. Now, to make rational choices, people have to consider both the set of what changes are feasible and what things are desired. The budget set, or the production possibility frontier, shows what's feasible. We can draw other curves to show what people desire. These are indifference curves, which link together bundles that a person likes equally so that they're indifferent. Starting from any particular point, assuming the person likes both X and Y, there's some downward sloping line showing other bundles with slightly more of one and less of the other that make them just as satisfied. Indifferent. Over the course of a week, a person might have 7 glasses of wine and 7 cups of coffee. If they had only 6 glasses of wine, how many additional cups of coffee would leave them indifferent? That would be different for different people. There's no fixed answer for everybody. Further, it's not likely to be a constant trade-off. Maybe a person would be indifferent between 7 and 7 or 6 and 8.5. So what about 5? How much more would they need? So indifference curves would bow out oppositely from how the PPF bows inward, but for basically the same reason of diminishing returns. Diminishing returns even work in smaller doses. That first sip of coffee in the morning is amazing. You can feel the caffeine hit and the life returns to your soul. But the last sip of the cup, it's great and all. It's not as amazing. Second cup of coffee, again, really good, but not quite as super. There is diminishing marginal utility. Now, on the issue of choice, sometimes you hear people grumble about numerical scoring. It's common in tastings for people to assign a number, like this wine is a 95. There are standardized scoring sheets for tasting. The taster assigns a number value of, a certain aspect of the tastings, and then those numbers are added up, perhaps weighted, to get a final score. That seems artificial and people cavil at the idea. But let's distinguish two separate complaints. You could say these numbers don't reflect my choices, or you could say no numbers could possibly represent my choices. Now, the first might well be true, but the second is generally false. We can prove mathematically with some very reasonable assumptions about choices that a person's tastes can be simplified down to just a number. It's known as utility representation, and economics has a number of theorems about it. It can break in any number of ways, involving probabilities and complications. But in tastings, the main way to break those theorems, to have a number unable to represent a person's choices, is for the flavors to be a surprise. So it's more common for people without much experience in tasting. But as people get more experience, they're less likely to be surprised by a new aspect of the flavor. And so their choices become more like a numerical scale. The other aspect that new tasters might find surprising is that different people can often agree on many ratings. Not every single one, but in various situations we can measure inter-rater reliability, showing to what degree people do in fact have similar opinions.